for my part, I would like to give to my group members to continue for the next part. Thank you.
Hi, my name is Nurhani Nabila binti Omar. Graphene has been employed in the design of different biosensors of various transduction modes because of its large surface area, electrical conductivity, high electron transfer rate, and capacity to immobilize different molecules. So this is the advantages in graphene biosensor. Large surface area has enhanced surface loading of the desired ligand due to the high surface to volume ratio, and the electrical excellent conductivity and a small band gap that is beneficial for sensitive electrical and electrochemical reads out. The third one is a cost-effective method for the rapid detection of microbe, viruses, or cancer markers graphene biosensor. And lastly, in the transducer, graphene can act as a quencher to generate fluorescent biosensor. When using graphene biosensor, some aspect of the graphene properties affecting the detection limit of the target molecules need to be taken into consideration. For instance, different synthesis batch of graphene and derivatives, as well as different synthetic method, can lead to different properties and functionalities of the graphene biosensor. The orientation between the graphene oxide or reduced graphene oxide sheet, and the bioreceptor can also directly affect the selectivity and sensitivity of the biosensor. Additionally, the number of layers, the functional group, and oxidation state of graphene and derivative will cause difference in the sensing performance among the sensor and even impact the bonding between the transducer and bioreceptor. The amount of functional group on the nanomaterial can also affect the interaction and the detection limit of the target molecule. In this context, it is often necessary to block any non-specific absorption sites on the nanomaterial to prevent unspecific binding of biomolecule instead of the target molecule. This can be accomplished by coating with blocking reagents such as bovine serum albumin, casein, or superblock, or treating the sensor with twin surfactant. By taking all these limitations into consideration, graphene biosensor can have high sensitivity and stability as well as fast response time, potentially resulting in advances in healthcare and diagnosis.
Proceed with the applications of graphene as a biosensor. And by the way, my name is Joyce. Okay, as for the biosensor technology, it can detect a biological event by the production of a measurable signal, and the process of obtaining the signal actually combines, which means the detection combines a recognition of element for a type of biomolecule or chemical reaction which a transducer which provides that signal. Not only that, the biosensors can actually be utilized for the identification of biological analytes such as antibodies, enzymes, organelles, and microorganisms. And furthermore, graphene is actually a carbon material in a honeycomb structure which is of 1/8 thickness that is successfully being developed in the production of biosensors. Well, as for the benefits of applying graphene to the biosensor application is that the single-layer graphene sheet actually displays properties that are particularly suitable for it to be used as a biosensor, which is it has a large surface area and high mechanical strength, superior elasticity, and also a very good thermal conductivity. It also has a high room temperature electron mobility, and lastly a tunable band gap where no electron states exist, and tunable optic properties. So the properties of graphene actually allow for the development of biosensors with improved performance. The relatively inexpensive production cost, along with a low environmental impact, also make graphene an attractive material of choice. And to use graphene or for the biosensor application, a chemical functionalization process must occur to enable biocompatible surface. And graphene itself can be functionalized by both the covalent and non-covalent bonding of small molecules to provide the compatibility for the successful immobilization of biological analytes or the receptors. Now I'll proceed with the first application, which is graphene-based nanomaterials as a biosensor. Well, in general terms, sensors consist of two elements, which is a receptor and a transducer. The receptor is the organic or the inorganic material that interacts specifically with the target molecule, whereas the target molecule can be inorganic, organic, or even whole cells. The transducer is the part of sensor which converts chemical information into the measurable signal as mentioned just now. The graphene-based nanomaterials are actually used as transducers of biosensor, which are involved in converting the interactions between the receptor and the target molecules into a detectable measurement. And for this to happen, the bioreceptor, or also the molecules such as the antibodies, single-strand DNA, and enzymes, need to be attached to the transducer surface itself. And the most common attachment method used for antibodies and ssDNA immobilization onto graphene and its derivatives, which are of graphene oxide or reduced graphene oxide, is the EDC or NHS chemistry, whereas the enzymes are mostly commonly immobilized by using physosorption. And the conjugated structure of graphene can actually facilitate the electron transfer between the bioreceptor and transducer, which can generate high signal sensitivity for the electrochemical sensors. And furthermore, graphene-based nanomaterial can act as a quencher in the transducer to generate fluorescent biosensors. Studies have also determined that graphene oxide, and reduced graphene oxide have a very high efficiency of fluorescent quenching. Um, the recent developments on biosensor technology with the graphene and graphene-based nanomaterials are mainly focused on antibody, DNA, and also enzyme-based biosensor, with the applications in life sciences as well as in clinical settings, whereby it is actually mainly aimed to present conceptual advances that have been made in the synthesis and applications of biosensors for clinical diagnosis and also the real-time molecular detection.
Okay, my name is Nura Aina binti Muhammad Khairi, and I will continue with the conclusion part. Okay, first, graphene has a unique physical structure as well as its chemical and electrical properties. Because of this, it makes graphene ideal for use in sensors technologies such as in life science and also medical field. Okay, second, besides sensors and biosensors, graphene and biographene based material have found an impact on electroanalysis and also electrocatalysis. In sensing application, graphene-based material feature with good conductivity and large surface area. This will give accurate, rapid, selective, sensitive sensing abilities in biosensing. But however, the usage of graphene has its own advantage and also advantages. But overall, the type of sensor selected is depend on the type of application. Uh, that's all for that's all for our presentation. Thank you.